Okay, so looking at theoretical probability versus observed frequency. So it says, in an experiment, probability deals with the theory of chance and is a measure of the chance or likelihood that something will happen. So when we're talking about theoretical probability, it's the theory, it's the possibility, the chance of something happening. So it's not necessarily going to happen, but what is the chance of something happening? So quite often you'll hear maybe someone say, well, in theory, we're going to beat that school in the soccer game tomorrow because we've always beaten the school, in theory. But it might not actually happen. You might play that game the next day and lose. So it's just the likelihood. What is the chance of something going to happen? Yes, you've always beaten the school in soccer. So you got a very good chance of beating them again this year, but it might not happen. Okay. And then in the same experiment, observed frequency is the data recorded from the experiment. So that means you're actually going to do the experiment and see what happens. So you could say, I'm going to toss a coin 10 times and it's going to land on heads every time. That's your theory. It's going to land on heads every time. And then you actually physically go and do the experiment. You throw it up 10 times and then you go and record. Okay, it was heads, heads, tails, heads, tails, tails. So theoretical probability is the likelihood of something happening, and observed frequency is actually doing that experiment and seeing what actually happens. Okay. So, important terminology to remember. This is a very good time for a screenshot moment. We're going to look at the first word, experiment. An experiment is a situation involving predicted chance or probability that leads to observed results called outcomes. Okay, so that's quite a mouthful. Yes, I see we have a raised hand. Who am I speaking to? Oh, mistake. Okay, no worries. Okay, so experiments, quite a big definition over there, but it's basically our experiment is what we're actually going to do. So we're going to toss the coin 10 times and it leads to observed results called outcomes. So we do an experiment to get our outcomes. What are the outcomes? How many times did we land on heads? How many times did we land on tails? So the experiment gives us the outcomes that we are looking for. Probability, the normal definition is the measure of how likely it is for a predicted outcome to occur. So what is the chance of something happening? What is the likelihood of something happening? The term random, the outcomes are unknown or unpredictable and do not influence each other. So for example, we could say, does the weather affect the chance of you passing or failing an exam? There's two different things happening at the same time, okay, but they do not influence each other. Trial, many attempts in an experiment, so all the attempts you do in the experiment, how many times are you throwing the dice, throwing the coin? Event is when a trial produces an outcome, so I've landed on heads. That was my event. It landed on heads, or my dice landed on the number 3. Our outcome, that's always what we are looking for in probability, is our recorded results. So it landed on heads 3 times, tails 4 times. And frequency is how often we are doing the experiment, how often the outcome is observed. Okay. So in general, they're not going to ask you probability terminology in your tests or exams. They might ask you for the definition of probability, though. That's quite a common definition that you need to know. The rest you just need to understand because they'll drop these words into your questions. Okay, do we have any questions before we get started with the next set of questions? Everyone happy? Are we understanding? Are we ready to go? Everyone is so quiet. So I'm going to take that as yes, cool, we're good. There we go. Yes, let's go. All right. So let's get to the interesting stuff. Experiment. A spinner has 4 equal sectors colored yellow, purple, red, and green. What is the probability of landing on purple after spinning the spinner once? So what is our theoretical probability of landing on purple? Okay, I see an answer already. Anyone else? What is the theoretical probability? So now we haven't spun it yet. We're just guessing. Educated guess. Okay, so I can see we've all answered in a different way. What is our default way to answer a probability question? What's the first way we should answer? In what format? Olabecheng's got it right. Yes. Okay. Fraction. So we always need to answer in fraction form first. And 1/4 is correct because we have 4 chances, 4 different colors we could possibly land on. Purple is 1 out of the 4. So there's 1 in 4 chances that it could, in theory, land on purple. Okay, so please remember, we always answer as a fraction first. The question will specify if it needs to be in a percentage or decimal. If it doesn't mention percentage or decimal in the question, we answer as a fraction, a simplified fraction. Okay. Then the spinner is spun 20 times. So now we're actually doing our experiment. We're actually going to spin the spinner. It is spun 20 times and the colors were observed. Okay, so we looked and saw the results, the outcomes. So it says, see the results of the events shown below. So we had yellow, then green, yellow, purple, red, green, purple, green, red, green, red, yellow, purple, purple, green, red, yellow, green, red, red. And you're lucky enough to get it all summarized for you. It landed on red 6 times. So frequency is how many times it landed on red. How many times it landed on green? So 6 times on green, 4 times on purple, 4 times on yellow. So now, determine what percentage of the observed events were purple. So now they've actually given us an indication of how they want it answered. They want the answer in percentage form. And we want to see the percentage of it landing on purple. What do you guys think it is? How do you work it out? Does anyone want to tell me? Bianca raised a hand. Yes, Bianca, let's hear. Do you want to ask me something? Ah, yes.
I think, I'm not sure, but then I think you need to take the frequency of purple and the frequency of the whole numbers and then multiply by 100.
Okay, so we take...
First of all, we need to calculate the whole frequency and then 4 divided by the whole frequency multiplied by 100.
Perfect. So have you worked it out? Yes.
No.
No, okay. So in theory, yes, you're correct. That is very, very well done, Bianca. Okay, so we add all the frequencies up. Then we take 4, divide by that, and we times by 100.
Yes.
Yes, well done. Good job. Thank you.
Thank you.
Good to hear from you. Okay, so when we add all the frequencies up, I can see you all got the answers, sorry. But what was our total frequency? When we add all those numbers up, yes. Total frequency. However, shortcut, we do know that they told us that the spinner was spun 20 times, but sometimes that information isn't given to us and they just give us the table. Okay, so that is the total frequency. So I've added all these numbers up. I then look at purple specifically because we want to know the percentage of purple. Okay. So it would be 4 over my total. And because we want it in percentage form, we times by 100. And we put that in our calculator and we get an answer of 20%. Does that help, Riela? Nice, Bianca. Thanks for giving us the method. And looks like we all got that. Well done. But when I did that, I got 500. Sakile, how are you putting that in the calculator? Are you using the fraction button on your calculator? Did you put 4 and 20 in a fraction? Yeah. So I'm not sure how that number, what's it, 500, could be an option. Oh, okay. Thanks, Katleo. Okay, so other way around. Thanks, guys, for picking that up. Well done. Super quick tonight. Does that help you, Sakile? Okay. So whenever we're working out the percentage of something, we look at what we're looking at. We're looking at purple over the total times by 100. So whenever we're working out a percentage, you take what we're looking at over the total times 100. Okay. Yeah, no, Sakila, not at all. You need to be timesing by 100 because we need a percentage. And it's switched around. And you haven't included 20. Okay. So always take what we're looking at. We were looking at color purple in this instance, purple over our total times 100. And that will be a general rule for working out percentages always. What we are looking at over the total of everything times by 100. General rule for percentages. Okay. Next question. Did the observed frequency match the theoretical probability? So let's remind ourselves. Theoretical was 1 over 4. And our observed was 4 over 20. Do they match? Okay, so I just rewrote it. Our theoretical was in blue, 1/4, and our observed frequency was 4/20. Yeah, 4/20. But remember, we always need to simplify our fraction. So it was actually quite close. It wasn't far off, but the answer is no, they don't match. Nice, yeah, more good. Okay, so clearly I'll just simplify the fraction. So we always need to simplify our fractions. But we didn't have to in the previous question because they asked for percentage specifically. If they asked us in this question just what is the probability, then we would have said 4/20. And then we need to know that we must always simplify. So we find a number that goes into both our numerator and our denominator. And I could see that would be 4. So I divide the top and the bottom by 4, which gives me 1/5. So if they did not specifically say percentage, this is what our answer would have been for that question. Alternatively, guys, when it comes to simplifying fractions, you could just put 4/20 in your calculator, press equals, and it gives you the simplified version. Okay, so you don't need to stress too much about knowing how to simplify the numerator and denominator. You can just put that into your calculator. That's one of the nice things about Mathlet is that you can use your calculator in your exams. Okay, let's have a look at another question. You guys are doing really well, so keep it up. Complete the following table for an experiment where a single coin was tossed 250 times. So we're looking at experiment, means we're actually now going to throw this coin 250 times. We're actually doing it. We want to get actual answers, actual probability. And it was a coin being tossed 250 times. What is the theoretical probability of a coin landing on heads? We're looking here specifically. What is the chance, the theoretical probability of a coin landing on heads? Good, half. Okay, and tails? So I'm going to say half or 50%. And tails will be the same probability. There's only 2 sides to a coin. So there's 1 in 2 chances of a landing on tails, 1 in 2 chances of a landing on heads. Okay, so our total there would be 100% or 1 whole. Okay, so now let's say, for example, we have done this experiment and I tell you that it landed on heads 120 times and it landed on tails 130 times. That gives me my 250 tosses. Okay, what are we lost with? So we're looking at a brand new question. No, you would not be wrong. You would be correct. 125. Where are you getting 125 from? Do you mean 120? Okay. Oh, the half of 250. No, we don't need to. Oh, well, you can say that, but remember when you simplify that fraction, it is going to give you 1/2. Okay. So I'm not exactly sure why we are lost. Let me quick. Okay, yes, Briella, you raised your hand. No, took it back. Okay, so we started a brand new question. We are doing an experiment. Briella, yes. You want to ask a question? Can't unmute. Okay, let's check. Does something come up on your screen now? I will explain now, guys. Don't stress. I can see your comments in the chats. I'm going to explain now. Briella, you there?
Yeah,
Okay, well,
Minama.
yes. Hello, I can hear you.
I would like to know, how did you get 100 and for your frequency? How did you get 130? Because
Okay, so that's what I was going to explain. So guys, for the 120 and 130, it was just a pretend scenario. I'm like, let's pretend I actually tossed these coins, and when I tossed the coins, I landed on heads 120 times. So that was me just doing the experiment. So these you don't need to work out. This is given to you. Does that make sense, Briella? Okay, perfect. Okay, so I can see we're asking these questions. So I did this experiment, okay? I tossed the coin 250 times because I was really bored one day and I thought this would be a really cool experiment. And then I landed on heads 120 times and tails came up 130 times. So I did the experiment. Those are just the stats. You don't need to do any working out. I'm telling you, out of the 250 coin tosses, I landed on heads 120 times and tails 130 times. Okay, so you don't need to stress about that. This is given information. Okay, Briella, do you have another question or is your hand still raised? Okay, perfect. So I tossed the coin 250 times. I landed on heads 120 times. I landed on tails 130 times. If I add those two up, it gives me my 250, which it tells us in the story. We tossed the coin 250 times. Briella, yes.
so it doesn't matter how you put it, ma'am. You can put the 132 heads and 122 tails.
Yeah, I could have said 200 times it went on to heads, 50 times it went on to tails. I'm just pretending I've done this experiment. So it doesn't matter. These are just numbers I've come up with. There's no calculation. It's just my example. So I tossed the coin physically and it landed on heads 120 times and tails 130 times.
Yes, ma'am.
Okay, cool. Thanks. Kakeho.
Hello, ma'am.
Hi.
How are you, ma'am?
Good, and you?
I'm good. Ma'am, I was trying something for how to get to the 250. So, ma'am, how about if I toss the head 110 times and then to tail for 140. So for both, it still gives me 250.
Yes, 100%. That's fine.
Okay, so that I
Okay.
wanted to make sure if we do it the other way around.
Yeah, no, that's fine. So it doesn't matter what numbers we have for heads or tails, as long as it equals 250. I'm just saying I just pretended to actually do it. And I said, okay, in my experiment, when I tossed the coins, I landed 120 times on heads, 130 times on tails. Doesn't mean that's always going to happen. That's just what happened when I did it. So when you do it, it could have been 110, 140. Someone else did it, it could be 250 on the other side, or 150 and 100. Okay, makes sense.
Okay. Thank you, ma'am. Yeah, it does make sense.
Pleasure.
Thank you.
Okay. Okay, so I was just explaining the scenario. We haven't even done anything yet. Okay, so it's just an example. I'm saying when I toss the coin. So let's pretend I've tossed it physically 250 times. Out of the 250, it landed on heads 120 times. It landed on tails 130 times. When I add those two numbers together, it gives me my 250. I'm just telling you that it equals 250 because I tossed it 250 times. It just proves that it's 250 times, okay? So it's just an example, like it's not always going to be 120, it's not always going to be 130. You don't need to guess. This will be given to you. I've given you this information. I haven't asked you to work out anything yet. We're going to use these numbers to now work out stuff. So this was just me making an example. Okay. So you don't need to worry about these numbers at all. In an exam or test, these numbers will be there already. They would tell you, okay, so out of the 250 times, it's 120 times on heads, 130 times on tails, or they could use other numbers. Okay, then I see that some of us were a little bit confused with the theoretical probability part, which is over here. So theoretical probability is working out the probability. What is the probability of me taking a coin, tossing it, and it lands on heads? I have how many options when I throw a coin? How many options do I have when I toss a coin? It can land on what? Heads or tails. So I have two options. Okay, but what is the chance of me landing on heads? Once out of the two options. So that's where we got half from. And half is also the same as saying 50%. And in decimal form, it's 0.5. I just put the percentage there because I know for the most part, learners understand and see the percentage better than a fraction. So it's the same thing though, just in a different format. So then for tails, again, the probability of me landing on tails, I've got one chance of landing on tails out of two because the other chance is a head. So it's one chance out of two. So I have half a chance of landing on tails. Okay. Then I've given you the scenario. I threw the dice, landed on one, heads 120 times, tails 130 times. So let's work out the relative frequency in fraction form. So that's the first part. This is the first thing we need to work out. Working out relative frequency in fraction form for heads. So how many times did it land on heads? It landed on heads 120 times out of. Good. 250. Good. Now, can you let me know the simplified fraction? Okay. Offense, yes, well done. It can be simplified a little bit further. Can be simplified more than 12 over 25. Kaliho, that's decimal. Okay, so we've got, sorry, 120 over 250. If you put that in your calculator as is, you literally say 120 divided by 150 equals. If it doesn't give you a fraction answer, you press the SD button and it gives you the simplified fraction of 4 over 5. So the calculator does all the work for you. There, it's simplified. It cannot be simplified anymore. Okay. Let's work out the relative frequency of the coin landing on tails in fraction form. Kimortile, yes, you have a question. I meant to say 250. Sorry. Kimortile, can you hear me? Okay.
Moratile, you can just start speaking. You are unmuted.
On here in my calculator, I 20 divide by over 25.
Okay, give me 2 seconds. I think okay. Thank you. I see you now. So I wrote 120, but in the calculator, I also said 150 and also said 150 out loud. So 120 divided by 250. Let me do this right. All the confusion. It's 12 over 25. Sorry, I don't know where I got that 150 from. So that is the simplified fraction. Because I said 150, sorry, it's meant to be 250. So now the calculation is correct. Let me check the answers for tails. We said 130 over 250. So we always write the original fraction. And then we simplify it. And we get, let's see, what did we get? Nice. 13 over 25. Good. I can see all the right answers coming in. Okay, so always write your initial fraction, the actual fraction down, then the simplified fraction. So you'll always get a mark for your answer and then the simplified fraction. So always put both down. Don't just jump to the simplified, or don't forget to simplify and just put the first fraction down. Okay, so it's marked like that all the way through to matric. It's a nice, easy mark, so just show both fractions. Okay, let's try get the relative frequency for heads in decimal form. So for heads in decimal form. Okay, great. Looks like we're not struggling with decimal form. Awesome. So again, you could just put it in your calculator. 120 over 250. Press equal. Sometimes you might need to press the SD button afterwards, or it gives you the decimal straight away. And we always leave our answer to 2 decimal places, always with decimals. Good. Then decimal format for relative frequency for tails. Nice. Well done. Good. Okay, so again, you will put your fraction down first, and then you will put down the decimal. So you'll always get a mark for the initial fraction and then putting it into the answer that they're asking for. Okay. Nice. Yo, we're all participating really well today. And then percentage form. For heads, yes, I see it coming through. Okay, good. So to get all your marks in the test, you will put the initial fraction down, and you will show that you are timesing by 100. And don't forget your percentage sign with your answer. So that's how you'll show all your working out, your fraction and times 100. So that could easily be 3 marks. Your fraction timesing by 100 and your answer. Okay, percentages for tails. Yes, 52%. Okay, so now that beginning confusing part is over, do we understand what was being asked in this question? Do we feel better about it or not yet? Okay, good. See all the yeses coming through. Okay. So let's do another experiment. Okay, so let's say I'm still going to toss a coin. So in this experiment, a coin was tossed, let's say 25 times. Okay, so let's pretend we're doing this experiment. So I'm going to quickly say, okay, I've thrown the coin, lands on heads, then tails, tails, heads, 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 heads again, tails. So this is me throwing the coin. This is what's happening.
That's 14.
Oh, thank you. I just had to take a brain break there, you know. Well, you let me know when I get there, Hugo. I can't multitask. Seems.
Stop.
Stop.
Yep.
Okay, so not that last one. Okay, so I've thrown this coin 25 times. I want you guys to quickly summarize it. Tell me how many times it landed on heads, how many times it landed on tails. Sure, you guys are super fast tonight. $13 times on heads. So tails must be 12 times. And just to double check that we counted right, if we add those two together, it gives us our 25 tosses. Okay, good. Now let's work out the probability of it landing on heads as a percentage. So the probability of it landing on heads as a percentage. Oh, we're getting the same percentages every time. Okay, so we would say, does someone want to explain how we would show this working out? How do we do this working out? How did we get to 52%? Bianca, yes. Bianca?
Yeah.
Yeah.
Oh, so you take the frequency of 13 divided by 25 and multiply by 100.
Okay, 13 over 25. And you times by 100. Perfect. And we get our 52%. Well done. Thanks, Bianca.
I love this probability.
It is nice. And you know what the best part is? Is that you do it in grade 11 and grade 12. And in grade 12, it will be in paper 1 and paper 2. Whereas the other topics are either paper 1 or paper 2. And the nice easy one is in both of them.
For sure, I'll be doing great.
Yeah, sounds like it. You're doing really well. Keep it up. Yes, nice, Lucky. Good explanation in the chat. Also, Sakile and Grace. Okay, what is the probability of landing on tails as a decimal? Probability tails as a decimal. I really don't know how that these numbers worked out exactly the same. Okay, who wants to tell me how they did that? Just use your calculator. Latabo, yes.
Hi, ma'am.
Hi.
How are you?
Good, and you?
I'm good. I just said 12 divided by 25 times 100, which was equals to 48%.
Okay. But we wanted this one as a decimal.
Oh, 0.48.
0.48. So you just put in your calculator and you press equals or what?
I pressed equals and then I pressed the SD button.
Okay, perfect. Fabulous. Thank you. Good to hear from you.
Okay, go.
Okay. All right. So good job, everyone. I'm now going to give you one more shot at this, but I have faith that you're going to do this in record time and have the best accuracy. So we're still tossing a coin. Instead now, I've only tossed the coin 55 times. So that is my total. So it lands on heads 17 times and on tails 38 times. So don't worry about theoretical probability, that still stays the same. So I've thrown the coin 55 times, lands on heads 17 times, lands on tails 38 times. I want you guys to complete the relative frequency for fraction, decimal, and percentage. I will ask you for your answers in a couple minutes. Let's go. Emmanuel, sorry, I didn't break up your name there properly. 48%, no, it's not a decimal, that's percentage form. So when you times in by 100, you get in the percentage. When you just take your fraction and convert that to a decimal by using the SD button or calculator, you'll get 0 comma something. That is your decimal. Okay. Don't tell me the answers yet. I want to give everyone a chance. Okay, so that means for heads, you are going to have an answer in percentage form, decimal form, and fraction form. So if you have your answers already, just give me for heads as a fraction, decimal, percentage. Katlejo, yes.
Yes, ma'am. For heads, for the fraction, we have 17 over 5.
Over 55.
Yes, of the 55.
Okay, and can that be simplified or is it simplified already?
You want it, is it as a things for percentage?
No, I just want to know, can we make that fraction smaller? Is it simplified?
Let me check.
Okay.
When you simplify it, give us 3,4.
Oh, so that's in decimal form. Or what?
Yes.
Where are you getting 3,4 from?
I did 17 divided by 55, and I did SD. It gives you 0, 30.
Yes, yes, yes.
So-
Okay. So that means that the fraction is simplified, so we don't need to simplify it. That is it in its simplified form. So correct.
Yes.
So then what did you get for decimal again? What did you say?
I said 0.30.
Okay, so let's just quickly look at that. 0.309 is after the 0. So we
Yes.
always round to 2 decimal places. So that means I'm looking at the 0, but I can't just say 0.30. I need to look what's next to the 0. And if it's above 5, that 0 needs to go up by 1. So 9 is higher than 5. So it's actually 0.31 when we round to
Yes.
2 decimal places. Got it.
Yes. Yes, ma'am.
Perfect. And then percentage, what did you get?
For the percentage, I got 30%.
Okay, let's check. Okay, so again, just everyone not sure if this was mentioned before, for percentages, we also need 2 decimal places. So the answer would be 30.909%, but I'm going to round that to 2 decimal places. So I look at the 0, that's my second decimal place. I look to the right because that's going to affect my number. Because it's higher than 5, it goes up by 1. So it's 30.91%.
Yes, ma'am.
Okay, cool. Thank you so much.
Yes, ma'am.
Well done. Thank you. Okay. So, yes, I'm seeing your comments now. We can't simplify the fraction any further. If you want to check that, you just put in your calculator, press equals, and if your fraction doesn't change, that means it's simplified. Then, another thing to take note of, decimals must always be rounded to 2 decimal places, okay, as well as our percentages. So we need to know how to round properly to 2 decimal places. Okay, it's not 30% or 31%. It has to be 30.91%. No, always 2 decimal places. Well, because there are decimals involved with the percentage, there will be decimals in your percentage. So it is almost like a decimal answer, but it's in percentage form. So it also needs to have 2 decimal places. Sometimes it's not around, like all the examples we've done up until now were exact percentages. Okay, so now we're trying to keep it exact, but now it's not whole numbers. It wasn't cut exactly. So we're going to have some decimals and must always be rounded to 2 decimal places. So we're going to see that now with the next column. So what was our fraction for tails? Offense, yes. No? Okay. So our fraction was, yes, nice, Bianca, 38/55. Okay, we put that in our calculator just like that and see if it's simplified. So 38/55 gives me the same answer, so it's in simplified form. Then decimal, what did we get? Let's see your answers. 38 divided by 55 gives us yes, nice. 0.69. Good. And then our percentage. 2 decimal places. Don't forget our decimals. So when I look at my calculator, I get 69,090. So I'm looking at my 9 specifically because that's my second decimal spot. Remember, 2 places after the decimal point. I look to the right to see if it's going to change my number. Remember, if it's 5 or more, it goes up by 1. But if it's 4 or less, it stays the same. So it is 69,09. It stays the same because it's less than 4. Okay. But you'll practice rounding as the year goes on. Rounding pops up in a lot of topics. Okay, so let's just look at this one quickly. Okay, so you are asking, so it's 0,6909. Why is it not 0,70? It would be 0,70 if we're looking at 1 decimal place. So if I was looking at the 6, so if I'm looking at the 6, that's the first decimal place. I look to the right of it, it's 9, it's higher than 5, so it will make it 0,70 or 7, same thing. But I'm looking at 2 decimal places, so I'm looking at the 9 in this instance. So you always look to the right of the number that you're dealing with. We're dealing with the second decimal place. So next to that 9 is 0, so it just stays the same. If it was a 5 over here, then it would go to 70, because then that 9 would be rounded up. But because it's staying the same, because it's 4 or less, stays at 69, stays the same. This was a confusing one. Okay, but rounding takes some practice. So always the rule is 2 decimal places. So you always look second number, look next to it, see this number is either going to stay the same or go up by 1. That is the rule. So look at your second number after the comma. What is next to it? That decides if it goes up or stays the same. Okay. That was, oh yeah, need to add the percentage sign. A really good lesson. How are we feeling about this topic? How was the lesson? Do you guys feel more confident about probability? Are we enjoying this topic? We're going to get full marks for probability in our exams. It was really nice teaching you guys tonight. It was fun interacting with you guys. You had so many nice questions. You did really, really well. I'm so glad you're enjoying it.